Good morning, student. Today we are going to learn about companding. After the completion of today's session, you are able to define companding, describe the model of companding, explain the characteristics of compander. So, what is companding? Companding refers to a technique for compressing and expanding an analog or digital signal. It is a combination of the words compressing and expanding. In this process, a voice signal is compressed, then changed from analog to digital in the transmitter section, and in receiver converted back from digital to analog before it is expanded again. Means in the transmitter section, first we compress the signal, then it change from analog to digital, but in receiver section, first it converted from digital to analog, then it is expanded. Okay. Then companding is used to achieve non-uniform quantization. Companding helps to improve SNR of weak signal. As we know, in non-uniform quantization, the step size varies according to the signal level. Means here the step size is not constant. It varies according to the signal level. If the signal level is low, then step size will be small. So the step size will be low for weak signal. Thus, the quantization noise will also be low. Quantization noise is given by NQ equal to delta square by 12. So here this delta is the step size. So for uniform quantization, this delta is constant. So for weak signal, in uniform quantization, the quantization noise increases. But in non-uniform quantization, the step size decreases for weak signal. That's why the quantization noise also decreases. This will improve the signal to noise ratio. Okay. Next is the model of companding. So this model consists of a compressor, a uniform quantizer, then expander. Means 3 blocks. It consists of 3 blocks. The signal is first given to the compressor. The compressor unit amplifies the weak signal in order to increase the signal level. While if the input signal is a strong signal, then compressor attenuates that signal before providing it to the uniform quantizer. This is done in order to have an appropriate signal level as the input to the uniform quantizer. As we know, detection of weak signal is difficult. High amplitude signal needs more bandwidth and also is more likely to distortion. The output of the compressor is provided to uniform quantizer where the quantization of the applied signal is performed. Means here the quantization is performed. At the receiver end, the output of the uniform quantizer is fed to the expander. Means in this companding model, these 2 blocks are present in the transmitter section. Okay. As we know, the signal is first compressed, then converted to then converted from analog to digital, but this part is the receiver section. Means before expander there is other sections are also present in the receiver. Because of that, first the received signal converted from digital to analog, then it expanded. Okay, so at the receiver end, the output of the uniform quantizer is fed to the expander. It performs, means this expander performs the reverse operation of the process executed by the compressor. This unit, when receives a low value signal, then it attenuates it, while if a strong signal is present, then the expander amplifies it. This is done in order to get the originally transmitted signal at the output. Okay. Next is the characteristic of compander. So here you can see the characteristic. So the graph clearly represents that the compressor provides amplification to weak signal and attenuates the strong signal. Means this one is the input line. So this part, this part, this is the starting of the input signal, means at the beginning the value of the input signal is low. So at this time or at this duration the input signal is low. So the compander amplify the input signal. Okay, but after some time the value of the input signal increases, means we can say during this time the input signal is strong enough. So when the strong input signal is given to the compander, means compressor, it attenuates. So here you can see the signal is increasing, but then it starts to decrease. Okay, so the curve is like this. Okay, then characteristic of expander. So expander performs reverse operation of the compander. So it is clear from the figure that expander provides amplification to strong signal and attenuates the low input signal. So when at the starting the input signal is weak, it attenuates the input signal. Okay, so the curve shows like this. But when the input is high enough, at that time it amplifies that input signal. Because of that the curve is like this, means it increases because of amplification. Next, this is the compander characteristic, combined curve of compressor and expander. We can say this one is the companding curve in PCM, pulse code modulation. Okay, so in this diagram here it one is the compressor curve characteristic and this one is the expander characteristic. We already discussed about that. But this dotted line, what is this dotted line represent? So the dotted line represents the linear characteristic of the compander, indicating that the originally transmitted signal is recovered at the receiver. Okay, so for digital audio signal, companding is used in pulse code modulation. The process involves decreasing the number of bits used to record the strongest signals. In the digital file format, companding improves the signal to noise ratio at reduced bit rate. For example, a 16-bit PCM signal may be converted to an 8-bit signal. Then someone can ask you that why not we use the non-uniform quantizer directly. So, because companding combines the efficiency of uniform quantization with the improved performance of the non-uniform quantization, because of that we use companding in place of direct use of non-uniform quantizer. Okay, so this is all about companding. Thank you.